Okay, yes, as was mentioned, I've been working as a developer for quite some time, and I had the same motto for all these years, which is if I have to do something twice, it's about time to automate it, right? So, but there is one task that I still have to do manually till this very day, and it is verify code standards. So, if you're in the project, you might see something like that, right? You have to comment on every single line, well, if you want your developers to learn code style too. So it helps them, and it might be a challenge in a bigger team with less experienced developers, especially, right? Because then there is a pull request, and you have to point out exactly all formatting issues, right? So, but can we automate it? Right? And if so, how? As always, there are multiple solutions to the same problem, but today I want to talk about the GitHub Actions and how you can use them to automate code style checks. So, if you are familiar with GitHub's UI, you might have seen so-called code annotations, right? So you see it here, code annotations. Many code static analysis tools actually use this GitHub's feature to point you to exact location of the code. Here you see a CodeQL vulnerability scanning tool in action. So what it does, it marks your code with vulnerabilities, and it points you to the file, the line number, and also it highlights the exact location on this line. So maybe we can use this feature to point out to the formatting issues, right? How would we do that? And how do these tools do that? They use GitHub's checks API, and it's very simple. We will talk about two endpoints here. You have two endpoints. One is to create a check run, and another one is to update. So let's take a look what kind of information is required when you call this API. So, well, you need to specify a repository. So it's here, you pass owner and repo. Then name, that's okay. But, well, you probably don't want to annotate your whole code base with all its history. You want to pin the exact version of it. So that's why you use commit SHA. And that's how you specify the version of the code. Then there is a status, and here you can specify it in progress, or you can also say, okay, it's completed. Usually tools use two-phased approach when they first kind of communicate the fact that the scan has started, and the second phase where they notify that, okay, it's done, here are the results. Why do they do that? It's because when you create a check API, it becomes visible on GitHub's UI, so your users are aware that something is happening in the moment. So we can also use this two-phased approach. Then let's talk about the update. It's also very simple. The only difference is that you pass, instead of head SHA, check run ID, which you got as a response to the create call. Then you pass multiple parameters to complete the check. And I want to just clarify a difference between status and conclusion, right? There are two different fields. Status belongs to the check run itself. So for instance, if you run a check, scan, and you were able to run it, then it is successful status. But the conclusion is what your analysis tool concludes, right? So it's a failure if you have any issues, or success if everything was smooth. And then how do you really annotate your code? There is a special section which is here. It's called output, right? Or output annotations, and here you specify the path, line number, and you also can specify the column So if you want to highlight a specific place on the line, you can use start and end column arguments. So, okay, clear. We can use this API to annotate the code and use it for our purposes, which is to highlight all formatting issues. But how do you trigger it? How do you trigger this check? Where do you call this API from? Well, if your code is already on GitHub, the natural choice would be to use GitHub Actions. GitHub Actions, well, luckily it has a free plan, so you can use that. But what is GitHub Actions? I actually have a question for the audience. How many of you have used that? Okay, so yeah, more or less familiar, but for those who know, no worries, there will be quick introduction into it. GitHub Action is an automation tool that helps you automate very basic things like building, testing, and deploying your project. And as many other CI/CD tools do nowadays, they use YAML format to describe what exactly you want to do. So let's take a look at this example. This is a GitHub workflow and see what it does. So first we see a trigger, and a trigger defines when this workflow will run. You can use multiple triggers. There are plenty of choices. You can combine them, mix them, and restrict their scope. Yeah, that's where your workflow will be triggered. Here we use push, which means every time you push something on your repository, this workflow will run. Okay, on any branch, but mind the fact that if you have multiple repositories and you want to trigger it from multiple repositories, you have to use this workflow in multiple places, right? So next one is jobs and what you want to execute and in which order. Here we have just one job. You give it a name, you give it an ID, and then you specify where you want to run it. Here you run it on a Linux machine, but you can also use Mac or Windows. Different versions, doesn't matter. And it has many things already pre-installed, so you can rely on that fact. And then you just start doing things. And it might be as simple as running a command like npm install or running a particular npm task. It doesn't matter. Or you can use reusable actions. And that's where GitHub Actions power is, because you can, instead of writing your own commands, you can use something that has been built, tested, and you can plug it in. If you want to use a reusable action, what you need to do, you need to specify the name of it. So like here or here, also version. And if the action requires so, you also provide the arguments as here. So this is very quick introduction into GitHub Actions and what you can achieve with that. But the question is, so if you write GitHub Actions, is there a code format for it? Sorry, I think something has happened to this monitor. I don't see it anymore, but that's all right. Yeah, is there a code standard for GitHub Actions? The answer is no, unfortunately, or at least not a widely used one. So what do? Well, you have to answer some of the questions when you start writing the code. And in bigger teams with many developers, you have to answer the questions before you start writing the code. Let's take a look at the last question. How to refer to the variables? Well, if you don't define the standard, in your project you might end up with different options. And I believe this is not the whole list of what you can have. Right, but generally, how do you refer to a variable? You use a $sign with a bunch of curly brackets and the name in between them. Do you need to put spaces between the variable name and curly brackets? Nobody knows. So maybe you have a preference. Do you? Option 1? No? Okay. Option 2? Nobody. Okay. 3? And 4? Wow, okay, majority. Yeah, that's cool, that's cool. At least it seems like we have a code standard. Unfortunately, it's not public, but we all follow kind of the same principle. I also prefer option 4, so I'm glad to see that we're on the same page here. Right. So we have it here. Just a second. Right. I think something happened to the monitor, but that's fine. I'll continue for now. Let's try to automate it. So now we know that there is a checks API, and we can use GitHub Actions to automate this process. Every time somebody creates a pull request on our repository, we want to run a code style check and check whether it's valid or not. So we will, on every pull request, run a simple thing, which is create a check run using checks API. Then we will use just a simple logic to scan all variable declarations. And then we will update the check run again with annotations. And then what we also want, we want to prevent unformatted code and ended up on main branch, for instance, and we will configure it on the repository. So that's what we're gonna do now. Right. Yes, thank you. Yeah, now I can see what I do. Okay. Okay. Right. You should see it here. We want to write it from scratch, but what we'll do now, we'll create a GitHub action, a reusable action. And if you want to create your own action, you usually start with declaring what you want. And this is a declaration file. It's actions YAML file. You give it a name. You specify the inputs. And note that we have just one input, which is a repo token. Why do we need it? Because we want to call GitHub API, and of course we have to be authenticated to do that. Right? Then we also specify where we want to run it. We say our infrastructure needs to be Node.js version 20, and then we specify which file to use to run it. So this is a declaration of our reusable action. Let's take a look at the code. Okay, where is it? Yeah. So everything is kind of written already. We'll just have to fill in the gaps. Okay. And on a high level, yet again, we need to do this. We create a check run with a name. Then we will scan our repository. And we will update the check run again with our code annotations. So as simple as that. Let's start with analyzing our code, finding all variable declarations and defining whether they are compliant with the standard or not. So if we navigate to this file, it's very simple. What we do here, we traverse a folder, very specific folder, .github. It's where all the workflows are. Then we go file by file. We only look for YAML files with A or without A, doesn't matter. And then for each file, we will scan line by line. And we assume that the variable declaration is on the same line. It might be not true, but for simplicity of this talk and this demo, let's assume variable is just one line. Okay. Then we will use a regular expression to find GitHub variable, and then we will use another one to define whether it's good or not. As always, if you have a problem and you solve it with a regular expression, you have two problems. So I guess you have 4 now. But I just want to show you one thing, which I personally like a lot. Okay, yeah, let me navigate there. So there is this tool called Regular Expressions 101, which helps you to debug regular expression. Hopefully you're familiar with that. You see an example here already with all the options that we've seen before. And there is already a regular expression. I'm not going to bother you with writing it, but it's a pretty simple one if you understand. If you don't, what's cool about this tool is that there is an explanation what it does. But our goal is to write a regular expression that would match all possible variable declarations. And that's what it does, right? So it found all our matches with or without spaces in any place. That's what we want. So I'm going to copy this regular expression and paste it here. Now, the second regular expression would be to find the correct ones. And as we defined, we want to have one space, exactly one space before and after variable name. So we'll just remove these stars, and we end up with one match. That's how we want our variables to be declared. So I'll copy that and paste it here. So once again, if it doesn't match this regular expression, we'll note down the file name, column, and variable itself, so variable declaration itself, and we'll store it in an array. So as a result, when we scan all our repository, we end up with an array of so-called style violations. Right, so that's how we find the problems in our code. Next one, we need to integrate with GitHub's checks API, and that's simple. We need to create it and then update it. Right. So let's give it a name. Let it be devjam GitHub variable check, something like that. And let's see how it works. Okay, here. Okay, so we have here a repo token. If you remember, we declared it in our action, and we have to get it here. Why do we need it? We will use an OctoKit library here, and we will initialize it with this token. So we would be able to call GitHub API. So, and the creation of a check run is very simple. You just use this OctoKit client. You say checks create. You specify the bunch of parameters that we need to provide, like owner, repo, name. Don't forget about SHA, because that's how we tag to the specific version of the code. And then the status. Here it's in progress. So that's how we create it. And as a result, we'll get, among other things, an ID of this run. So that's what we will return from this function. Then the update, pretty much the same. We use a run ID here. Remember about conclusion, right? So if we found anything, like even one violation, we'll say it's a failure, otherwise it's success. And then to create an annotations array, we will use a mapping function here, which is very simple. It's just one-to-one mapping. Pause, start line, end column, oh, sorry, start line, end line, and also column, end column, start column. Then there is also a bunch of fields we can set, like annotation level. It defines how your annotation will look like on the UI, whether it's notice, warning, or error. You also can provide very useful tips about how to fix it. Let's say in the row details, you can go, and I don't remember the limit, but you can really paste a lot there. And you can use Markdown to make it nicer. So that's pretty much it. That's how you write an action that would communicate with GitHub and also scan your code. So let me just commit it and push it to the repository. Now, what we'll need to do, we need to create a workflow that would trigger this, right? So if you remember, it needs to be stored in a very specific folder, so under .github folder and then workflows. So we already have one folder. We'll create a new one, call it GitHub style YAML. So we can create this workflow. Let's call it GitHub variable check. Then we define a trigger, and a trigger, if you remember, we want to trigger it on every pull request. So there is a pull request trigger, and you can see from the suggestion list, there are plenty of options you can select. But yeah. Oh, yeah. So I'm not sure if it's visible here. Unfortunately not. But what you can do, if you use IDEA, for instance, you can configure a schema that you use, and then you'll have all these suggestions. Maybe I can show you afterwards, but what you do, you have to define the schema, because these suggestions come from a YAML schema itself, right? So, yeah. Okay, then we give a job an ID, which we'll call GitHub style. The name, check GitHub style. And then we have to check out the repository, because we need to scan it, obviously. And we need to call our created action, GitHub reusable action. Let's give it a name, check variables. Then we need to specify what to use. And because it's a local action, we need to provide the path to the folder where this action is stored. So I don't want to make any silly mistakes. I'm just going to copy it as is. And if you remember, we also had one argument, which is a repo token. And you won't believe it, but it's a variable that comes from secrets GitHub token. What is it? It's a predefined token that is pre-created on any GitHub repository, especially if you use GitHub Actions. What it will give you, it will give you a possibility to call a GitHub API on behalf of GitHub Actions. And that's actually the workflow. So we will trigger it on the pull request, and once it's triggered, we will use our previously created action to do the logic, so workflow. So, okay, I need to rebase, that's expected. Right, now let's navigate to the repository. And if I update it, I should see the commit. Yes, here it is. Now, the workflow is there, the action is there. Let's test it, how it works. For that, we'll need to create a pull request. Okay, let's navigate to the folder. Let's check this TS compile, for instance. We see some declarations here, and everything is fine now as we want it to be. But imagine somebody comes to our project and wants to mess around with our code styles. What do we do? Well, you'll see in a moment. So we'll remove the spaces here. And we will commit the changes on a new branch. So the branch is created with our changes. Now, when we create a pull request, it will in turn trigger a workflow. Then this workflow will run our check, right? So I see that the workflow has started. And that's actually how you see the progress, right? So workflow has started. Now we see that our check started. If you recognize the name, right, DevJam 2023, and we see immediately that it failed. Okay, now we can see what really happened. You can go here and see the details. There are two issues. You can see that, yes, indeed, bad formatting, and you can see what happened. Well, that's not quite convenient. You probably want to see it on a different tab here, which is also available here. So instead of writing your own pull request commands, now you have it automatically. It's a notation, and you cannot resolve it. It's there because it's automatic. So the problem still is that you can ignore it and just proceed with the merge. Let's configure it. If you have admin rights on your repository, you can navigate to the settings and create a branch protection rule. So, yep. That's correct, and we will talk about it in the limitations section, but that's very, very correct, yes. But let's create a branch protection rule. For instance, we create it on a develop branch. We will require a pull request to be created before we allow any merge. And then, that's the interesting part, require status check to pass before merging. So here we can actually start typing, and we will get our check here. So we can say we only allow the merge when this is successful. So that's what we want. And what I also like to do is to restrict it for everyone, so even for myself. Let's create it. OK, so it's created. Let's navigate back to the pull request, and hopefully I won't be able to merge anymore. And you can see that I'm clicking on it, and nothing happens because it's, of course, disabled. So we configured it, and you can see actually that it says required check. And you can see that it's not passed. Right, let's fix it and see that it works, that the action works. And once we resolve all the issues, we can merge our pull request. So we'll return back our spaces. So here, two spaces. Where do you see two spaces?
GitHub open at the start.
I'm pretty sure it's one, but yeah, but that's fine. That's fine. We wouldn't be able to merge, right? If it, do you want to run another test? Or? No, that's fine. Okay. So I'll commit the changes on the same branch. Because I'm updating this, remember this pull request trigger, it will work again. So we will trigger our workflow again to run the check. And you see it's already running. Oh, and it's paused now. So let's navigate back to the file changed. You see, well, there are no more annotations. But remember, because the annotations are linked to the specific commit, you still can see them. So if you open this view, if you go here, here they are. You still can view them if you want. And if you go back to the pull request, now the button is enabled. You can proceed with merging, right? So because all our checks that we defined we want are now successful, right? So here we are. Okay, let's get back to the slides. Nope. Ah, okay, yeah, I'm already in Chrome, of course. Okay. Just give me a second. Yes. Let's talk about the limitations. Right. The first one, that you can post 50 annotations at a time. Hopefully it's not a major, but yeah, if you have more issues on the code, you can do it in batches. It's fine. Maybe you have another problem if you have more than 50 issues in the pull request. Right, automatic reject. Or another one, and this is important, check API only works from GitHub Actions. So, for instance, if you have your own personal access token and you can, poke GitHub API, you can't with your own personal access token. You need to have permissions of GitHub application. So how did we do that? If you remember, we used this repo token, which was pre-configured, and we did everything on behalf of GitHub Actions itself, which is, in turn, GitHub application. So that's how we were able to run this. Yeah. And another one that Tony has asked already, it's that PR blocking feature only works on either public repository or a paid plan. You can still have it in a private repository without any paid plan, but it will show up as a warning. You still can proceed with merging. It won't enforce it. I think it's important to mention that there are, of course, alternatives to this solution, right? It's just one way to implement it. There are many other ones, but let's talk about it in the scope of GitHub Actions and what you can have. So, for instance, instead of using checks API, you can use pull request commands. That's a valid approach, especially if you're concerned about this limitation of using checks API. Then you can use PR commands, but don't forget that you have to resolve them once the issue is addressed, which might be a bit trickier. The next one is actually to create a GitHub application. It's a very flexible approach. The problem with that, it will require initial setup, configuration, and you also have to host it somewhere. You need to deploy it, and you also need to expose the application itself to the internet, because GitHub will call your application in order to communicate the events via webhooks. So that's an alternative, of course. Or you can use an existing GitHub application. You can check out what's out there on the market. You can configure it for your repository and use it as is. And it might be exactly what you're looking for, so don't reinvent the wheel. You might also say, well, I don't want my code to be annotated. I just want it to be properly formatted. That's it, period. Then it's a completely different approach, and that's where you would use linters. Well, linters would automatically format the code for you. But I'd say this approach should be used in more experienced teams, in my opinion, with different processes. Why? It's because it's my opinion, right? If you run a team with junior developers, you want them to learn code standards, and the only thing, the only way to learn is to point to the issues. If you use linters, nobody sees where the issues are. If you use linters, go no further than superlinter. It supports all types of languages and formats, so grab it, and it's very flexible. So with all these alternatives, you might ask, why checks API? Why did I present it to you? Well, first I wanted to share this very knowledge about the checks API itself, what you can do, but more importantly is that you can automate many things, maybe as simple as code style checks in your project to make your life a bit easier. So I hope I've inspired you to automate more, and keep automating, and remember about code standards. Thank you.